Now, we see that all of our study here for the rotation can be compared with the linear motion. So for the linear motion, to measure the inertia, we have the total mass m. Okay? And so here we introduce rotational inertia I, which is kind of similar to the mass in the linear motion. And for the linear motion, we have an important quantity F, okay, to change the motion. And when you have a force acted on the rotational motion, you can try to accelerate or decelerate the rotation. So it also has a quantity called the torque. Okay, torque. We use the briefly torque. So this can be compared with force. This can be compared with the mass. And torque is related to the force. To produce the torque, you have to apply a force. But it's not only determined by the torque. Similar to the rotational inertia, it's also determined by the radius. Okay, how far you are going to apply that force, how far from the center you are going to apply that force. And the precise expression is given by the cross product. Okay. The torque equals to R cross F. Okay, so what is R and what is F? For example, you have an object here, and this is rotational center. Okay, so R is the radius. So from the rotational center to this object, this is R with the outward direction. Okay, the vector you have the direction. The force is of course whatever force you try to rotate it. You can rotate it with a perpendicular force, or you can rotate it with some force like this, or you can rotate it with some force like this. Okay, this is R, this is F, this is R. Okay, so the effect, you can see for all these three forces, if they are in different direction, it will produce different torque. Okay, R cross F, because we know that the magnitude of the cross product is given by the magnitude of the two vectors R and F multiplied by sine theta. Theta is the angle between the two vectors, right? So it's determined by the direction. So even you have same magnitude for R and same magnitude for F, depending on different angle theta, you still have different number for the torque. Okay? Now, but several things you need to pay attention to. First, what I would like to say is that, okay, that's the magnitude. What is the direction of the torque? Okay? If you remember how to determine the direction of the cross product. So can you tell me, for this one, and this one, what is the direction of the torque? Think about the cross product, how can you determine the direction for A cross B? So what device you need to use? You have to use something. You have to use your right hand, okay? Right hand rule, if you have A cross B, you make your finger to A, and then you have to arrange your hand in a way you can bring your finger to B. And then this direction is the direction of the cross product. So that means here you have to first make your hand to finger to direction of R. For example, in this case, okay, so your hand should be somehow arranged like this, direction of R, right? And then you want to arrange your hand because you still can have different position with your hand. So you can bring your finger to direction of F. Okay, so you have to arrange it like this, right? So you can bring your finger from R to F. Okay, this is direction of R. So this is the direction of the talk. The talk is pointing to you from the blackboard. Okay, so please note that the talk is in the direction perpendicular to the rotation. The rotation is along the plane of the blackboard, but the talk is perpendicular to it. In fact, talk is the so-called the pseudo vector. It's formed from the cross product. Okay, the direction is perpendicular to the motion. It's quite special. What is the direction for this one? What is the direction for this one?
Torque. Still in the same?
Yeah, it looks the same.
Still the same, okay? Because you still want to bring like this. You just want to. This one is also bring like this. This one is bring like this. How about this one?
Same.
Still the same. Okay, you just need to bring like this. With further finger movement, but your hand will place in the same direction. So all of these three, they have the same direction, and the meaning is that the talk will make a counterclockwise rotation, right? Okay. So if the talk, you can see that if it's inside from the blackboard, they will make a clockwise rotation. Okay. Now that's the first thing we need to pay attention. Any question here? We need to practice that. Okay. Another thing is we emphasized the cross product is not commutative. A cross B is different with B cross C, A, right? So this one you remember is R cross F, it's not F cross R. Okay. That's somehow you have to, you don't have to memorize, it's given in the equation, but you need to realize there is some issue here. Okay, it has to be R cross F, cannot be written as F cross R. It's not a commutative multiplication. Okay, the third thing I would like to emphasize, if you try to use this equation to calculate the magnitude of the torque, so you need to make sure you can correctly identify the angle theta here. Okay? So for example, for these things, how can you label the angle theta? Okay?
Yeah. Angle between R and F.
Yes, it's between R and F. And, anyone would like to draw the angle theta for me? Yes.
Seems like a trick right here.
Yeah, I smell something fishy.
Okay, a little bit tricky here. It's
It's
not
on the outside.
Okay, let me see if you get it correctly.
There's only two ways you can draw it.
Yeah, it's either.
Wow.
So please note that to draw the angle, you have first extend the radius. Okay, that's the direction. Direction you can always extend it. So this is angle theta. The common mistake is some of you, if you don't careful, you want to, like say, plot theta here. That's not right. Okay. Similar for this one, this is theta. For this one, this is theta. Okay? So there are the things you need to pay attention to. Now, this expression can be transferred to another more useful expression. Okay. So you can try to calculate the torque in terms of so-called moment arm or lever arm. Okay. Okay, I think you've heard about this before. That's how you, when you have some leverage, how you calculate the torque. Okay, multiplied by F. So here R perpendicular, okay, is called the perpendicular distance of the force from the center. Okay? So let's look at, if you have this situation, first let's look at this one, okay? This is the force, this is object, this is rotational center. We try to find out R perpendicular. This is R. In general, R perpendicular is different with R. Okay. Because R is the radius measured from the center to the object. You just connect the 2 points. But R perpendicular is the distance from the center to the straight line of the force. Okay? In the geometry, you should know that if you have a point here, you have a straight line here, what is the distance between the two? You have to draw a line perpendicular to the straight line, right? So, in this case, it may or may not along the force vector, but it always, so you need first to extend it, okay? In this case, this is R perpendicular. Okay, it's even not on the arrow of the force. Okay, so this is R perpendicular, this is R. Usually R perpendicular is smaller than R. Okay, and for this case, let's look at how can we draw the R perpendicular. If this is R, okay, this is the force. F. Okay, so that's a straight line we need to consider. This is the center. So in this one, this is R perpendicular. Okay. And of course, to calculate the R perpendicular, you need to look at some triangle and use the trigonometry to find out R perpendicular from R. You need to figure out some angle here. Okay? And one special case, again, this one R perpendicular is smaller than R, right? There is a special case like that if the force is perpendicular to the radius. In that case, can you see that for this case, the R perpendicular will be the same as R. So R perpendicular equals to R in this case. It's the same thing because the force is already perpendicular to R. So that's a very useful one because in many cases we are going to apply the force in a way perpendicular to R. So R perpendicular will be the same as R. Any question here? Okay, let's think of different situation. How can you identify the torque? Okay, now